whenever we have a new retrieval model, it is to overcome the limitation, primarily limitation of the previous retrieval model, right? Because a particular retrieval model may be suitable or may be okay for the retrieval process for some duration or maybe some sort of data, right? So whenever we face a new type of data, you need to adapt for, or you need to go for the different type of retrieval model, right? So because again, each and every retrieval model is having its own way of representation of query and data document. That's what we have discussed also, because in any retrieval model, naturally this ranking and matching is the inherent process, but along with it, the representation of data and representation of queries also, it is also the important part of any retrieval model, right? So that's why we are saying one particular data retrieval model will be compatible or suitable or okay for one type of data, right? When we face new type of data, you need to go for the different representation. It means you are going for the different retrieval model, right? So each and every limitation, each and every advantage of a particular retrieval model is limited to a certain generation. Whenever we face some limitations in a certain retrieval model, we will be going for the next type of, or next next modified version of the retrieval model. And that's what that was the reason behind all these evolution of all these modern or all these latest or adapted or modified retrieval models. So till now, I mean, if you take the literature or if you take the generic observation on the such systems, till now we are having around 23 or 24 different fundamental retrieval models. I am saying fundamental. Fundamental means we are not talking about the modified version of the model. So like in case of Boolean is a fundamental, or it is a classical retrieval model. When you modify, when you perform some changes on a Boolean retrieval model's structure or architecture, you can say it is modified, it is enhanced or extended. So then only we cannot say that this is a classical, right? So you can say the very first version or the very basic version is still in use. When we add something into the basic, it will become advanced or enhanced or modified, something like that, right? So out of these 23, 24 or whatever number it is there, we will be going to discuss only 4, and these 4 are unique in some way and related in some way, right? So we will begin with the very first retrieval model, which we are saying as a Boolean retrieval model, right? So before going to the internal working, because it is too obvious, it is too simple, and naturally it will be having some limitation. That's why we are going for the vector space, right? So before going to this discussion, let's understand, or let's have an understanding that what is the obvious way of retrieval? What is the obvious way of a retrieval model which should work? As a user, we have naturally some perception that this is how a simple retrieval model should work. So for a given query, it should match the documents. It should it should run a basic matching algorithm to retrieve or to match or to extract the different documents. Naturally, within matching process, it should have some mechanism, right? Because matching is an algorithm, that is obviously it is a procedure, but to perform matching also you need to have some approach, some strategy, right? And what if query is having more than one keywords? What if query is having only one keyword? How it is affecting the overall matching process if a particular keyword of a user query is appearing more than once in a document? That is, does it affect the overall matching process? So there are various aspects or side or maybe dimensions of this whole retrieval model, right? Particularly within matching process, within ranking process. So we have taken this statement in previous lectures that each and every retrieval model, if you compare all these 23, 24 retrieval models, you will realize the difference is only in the ranking and matching process within these two processes. Because representation is somewhat, we have 4-5 ways of representing the document and representing the query. But when it comes to the matching and ranking process, these two processes are having some novelty involved in different retrieval models, right? So if we begin with the obvious way of performing the retrieval process, performing the matching process, one possible approach could be like for a given query. So naturally, query will be having keyword or query term, specific English terms, and these terms will be simply matched, simply compare or simply text match or string match within the documents terms basically. So for user query, suppose user query is having one term, any term like India or maybe president, something like that. So this particular term, user query term, will be matched with the terms available or stored or maybe located in each documents or each result set, right? So primarily you have to make your query in the form of stems, so in the form of terms actually, and similarly your document, each document of your document collection or maybe web page should be also having these terms. You should be performing some pre-processing to remove the those words, star words and all those things. So you have to make sure that both representation are same, and based on that you can simply perform a matching process. That's one way. Second, if user query is having more than one keywords, right? So T1 and T2. So how these two keywords will be based on your matching process, how these two keywords will be appearing into the document. Is it in the form of and, like T1 and T2, T1 or T2, or maybe reverse, or maybe is it important to have both in the same, like T1 and T2 should appear in the document in the subsequent places, positionally subsequent. One could be like one possible alternative could be T1 appears in anywhere in the document, T2 appears in any place, any position in the document. So it is important to match the document if T1 and T2 are present into the particular document, right? So there are a number of possible ways of it. There are a number of ways of implementing this possibility that when a query is having more than one terms, how you will be implementing it, right? One term is okay, one term is not having. So if user query is having single term, it does not have any complication. It is a simple match process. When it comes to a user query with more than one query terms, then you have to decide the strategy. Then you have to have operators. That's what we have said, right? And most of the search engines, most of the search processes are, having this novelty, this newness in this part, how they are dealing with the query with more than one terms, how they are dealing with the query with a phrase. Sometimes user write a phrase, something like that, right? So in the case of Boolean retrieval model, we are dealing with the very fundamental, the fundamental representation of the user query, right? So let me share today's class lecture, and then we will slightly overview the internal working of Boolean retrieval model, right? So one thing which we have said in the previous lectures also, that the Boolean retrieval model will be basically is the fundamental or classical way of doing the retrieval process. So it is primarily based on exact match, right? That's what we are saying. Whenever a query is appearing, those query terms will be exactly matched within the documents, right? So it is this exact match will be performed between user query and document set. Whatever documents, web documents, web pages, whatever documents we have, this basically it will perform. It is rather set, we can say, collections, document collections, right? Now, one important factor here it is that this Boolean retrieval model does not support any ranking way. So it will simply retrieve the document it will not rank the retrieved documents. So based on a matching process, it will select the top, it will select 20 or 100 or maybe any number of documents, but it will not rank them. It will not rearrange them, right? And the basic principle behind it is that each and every retrieved document is relevant to them, relevant to the user. That's the philosophy by which it is working, and that's why it is not offering or providing any ranking among the retrieved documents, right? And this is something says as a classical principle. So whenever we start designing algorithm, a new algorithm to the area, you should have this, you can say this diversity, or you can say, equal opportunity for each and everything. So like in modern days, we are having a lot of applications, lot of AI enabled system. They are trying to provide you personalized support, right? And it is not good sometimes. You should be in this process of personalized support to any recommendation process or to any search or any kind of computing. Sometimes it has become too personalized, right? And it is too bad sometimes. So you should have this balance, or you should have this capacity to diversify the result. You should not personalize. You should not too personalize to a process, something like that. So this Boolean retrieval process or the Boolean retrieval model says each and every retrieved document is relevant to the user, and I'm not going to rank it simply. So all the documents which are retrieved will be presented as it is to the user, right? There might be some internal arrangement, there might be some internal representation. So but Boolean retrieval model does not impose any ranking step or any ranking strategy on the retrieved or extracted document, right? So primarily it is having only two levels of matching, or two levels of matching degrees, matching or non-matching. It is equivalent to relevant or non-relevant. This is something we have discussed, correctly pointed out. Now, how it is representing user query and data collection or data documents collection. So to represent it, it simply use either words, sometimes said as terms also, or maybe stems, right? So we can have two approaches. So user query also derive in the form of terms or maybe stems, or your document collection. Each document is processed and stored. So surrogate data will be available in the form of either in the form of words or terms, or maybe in the form of stems, right? So in the case of Boolean retrieval model, it does not require to maintain index data. That is something it is closely observed, right? So you can simply have a list of words, list of terms, or you can have stems, right? So this is what about representation model for query and data. Now, naturally, there is a very specific cases where queries will have more than one term. User query will have more than one term. You need to adapt for some operator. So those operators are referred as a Boolean operators. So we have three possibilities: and, or, and not. So these are the three sets of fundamental sets of Boolean operators. So in the case of more than one query terms in a user query, you need to, or system need to have some arrangement to plug them. So like you can have term T1, term T1 and term T2, something like that, right? So you should have, or maybe system should have this tendency to plug them into this Boolean operator, right? So you can have the fundamental definition of operator, right? Sometimes people are doing like they are defining the new AND operator. So that's what I'm saying. Whenever you are going to modify operator, Boolean operator, you will have new Boolean retrieval model. So you can define your AND operator with respect to your own understanding and use this modified AND operator in your model, retrieval model, and you can easily claim that I have derived a new Boolean retrieval model just because I am using a new Boolean operator to retrieve the matching set of documents. right? Because the success of Boolean retrieval model falls into the definition of Boolean operator. So similarly, you can go for OR operator definition also, for NOT also, right? So because it is very rarely possible that user query is having only single query term. Most of the cases, user query will have more than one terms. It means there is a very important role of these operators into the success or effectiveness of a Boolean retrieval model. Now, if you take a basic example, so I hope things are clear till now. Now I am going to take this specific example. So let's read it carefully and try to relate and try to understand. Now, if you see, we have taken three different queries. Query Q1 is having two terms called T1 and T3, and query T2 is having T1, T3, and T5, and query 3 is having a very specific type of need, like T3, T7, but not T9. So in query 3, it does not require to have T9. So it is, that's why it is written out of T9, something like that. So it is textually we have written, but it is like a complement of T9, right? So so these are the documents. You can easily see the documents are like D1, D2, D3, D4, D5, D6. And each document is having these set of terms or these set of stems probably. So you can easily read, like D1 is having terms like T2, T4, T5, T6, T1, T3, T7. So there is no specific order. They are just derived. So T1 is like T1 is indicating to a specific term or a specific word or a specific stem. Similarly, if you see in document D2, you can see T1 is appearing multiple times in a document. Right. Similarly, T3 is T4, T3 is also having multiple occurrences within the documents. So naturally, if we are having this arrangement, each and every term is having some positional values also, right? So you can easily see we are having documents, and within documents, a particular term is appearing more than once, right? So this is what we are. It means we are simply have this transform version of documents. We are not keeping indexes. Right, so that's what I had said also, that in case of Boolean retrieval model, you do not need to prepare the index data. In case of index data, we do not need to have the multiple occurrences of a single term within the document. Instead of that, we are maintaining the frequency or maintaining the statistical value along with the terms. But here you can see we are maintaining each and every occurrence of a term within a document. So that is about the representation of query and document set. Now for query Q1, you can easily trace out that for user query Q1, which is like having term T1 and T3, we can say like document D1, D2, D3, D4, D5 will be extracted. Not? Is it correct? What about D6? I'm not getting any answers. So if you respond to this sheet of this,
there is no T3 in D6 now. And I think we are taking AND operator in this case.
Yes. So that's why D6 is not retrieved, right? Because in D6 you can see T1 you can spot, but T3 is not existing in the document, right? And other documents like D1 to D5, we can see the presence of T1 and T3. Maybe they are not like in the case of document D1, both are appearing consecutively. But in case of D2, T1 is appearing in the different positional presence. All right. Here we can see the subsequent presence of T1 and T3. But in the same document, we can see T1 is appearing in the second position and T3 is appearing in a different position. If you see the D3, in particular D3, we are having the presence of T1 multiple, but there is no subsequent. Yes, it is there. So subsequent present is there. So it is not having any effect actually. So Boolean retrieval model says the presence of user query term, irrespective of positional presence or position index, they will be selected, because it will be searched for T1 and T3, right? We are not searching for the presence of T1, T3 subsequently, something like that. So that's why these first 5 documents like D1 to D5 will be selected for the user query 1. If you go for query Q2, so can you tell me the answer? What could be the selected documents? Anyone? For these 3 query terms in query Q2, which will be selected? Just let me know. So D6 not be selected surely because it is not having the presence of T3. What about remaining documents for the query? Just let me know.
Sir, I think only D2, D3, D1, D2, D3, D4.
Yeah, just repeat.
Document 1 to document 4, D1, D2, D3, D4.
D5 will not be there. So D1 be selected?
It's not there.
D1 will be selected, right? D1 will be selected because it is having 1, 2, 3, 1, 3, 5, right? About D2. Okay, what about this last query, Q3, where we are having T3, T7, but not of T9? You can respond to the chat box also.
Sir, D1, D2, and D5.
Yeah, let me write it here. Say it again. D1,
D2, and D5.
okay, only D5. Okay, I hope it is correct. I'm not verifying it. Right. What about this? Can you again verify about query Q2? Just can you verify for the query Q2 where we are asking for T1 and T3, T5? Is it correct? Having these 4?
Yes, sir. I think third is also okay. We are not taking the ones which have T9 term.
Right. Okay. So let's take this these answers as a correct. So basically, this is how a particular Boolean retrieval model works, right? And we are because we are having these queries with more than one term. So we are assuming that this the presence of more than one term is accepted as the basic definition of AND operator, right? So it is like T1 and T2, something like that. So it is not having any new definition for the AND operator. So if we take the basic definition of AND operator, this is how the Boolean retrieval model will work. This is how it will retrieve or extract the matched documents, right, for these different queries. Now, the basic observation says it is not basically having any ranked arrangement for the retrieve or extracted documents. That is too obvious. Second, it is not applying or it is not having any effect on the number of query terms frequency basically within each document. So like we have taken that in particular document, we are observing the more than one presence of a particular query term, or even the pair of the query terms are appearing more than once, but we are not considering these presence of these query terms within the document for any kind of ranking, any kind of rearrangements, right? It does not have any effect, which is not good. That's because whenever a user query is appearing more than once in a document, it should appear in the higher order of the relevance. That's what we are expecting as user, right? But when we said that Boolean retrieval model is working on, it's the most fundamental way of retrieving the documents. It will. That's why it is not considering any ranking strategy, any ranking statistical evaluation, right? So for that, basically, we can have different retrieval model, or maybe we can have different strategy for the Boolean retrieval model itself. So sometimes you can have always an enhanced Boolean retrieval model. There you can have the ranking strategy also. So if you explore to the research literature, you will find certainly ranked Boolean retrieval model, something like that. So some people have tried to incorporate the ranking module into the retrieval model, Boolean retrieval model, and said this is the new retrieval model, right? But theoretically, it is well taken care by the next retrieval model, which we are going to discuss. It is vector space, right? So now, before going to that, you should have this, understanding at this point that what are the possible limitations, what are the limitations we are observing onto the Boolean retrieval model. So few are very much obvious and visible also. So one thing is that whenever we are trying to understand the effectiveness of the model, that how effective this Boolean retrieval model is, so it entirely depends on the user's query formation capability and his knowledge about the domain where is he searching for, right? Because whenever we throw some query to the system or to the retrieval model, it will simply perform a match and retrieve the documents, right? So primarily the whole effectiveness, accuracy of the relevance retrieval will depends on the correctness or the exactness of the submitted query terms by the user. So this is something very critical, and this is something observed by the different researchers also, that it is very critical to have a trained or skilled or informed user in case of Boolean retrieval based search systems, right? That is something as a limitation also. Now, second thing, so basically for the first limitation, you can say there is an advantage of, because when we say the system effectiveness is directly related to the users awareness about the system, awareness about the knowledge domain also. Sometimes it is good for some users, because user feel that okay, system is purely driven by his knowledge or his input. So user feel confident about the system. But as far as the effectiveness is concerned, it is not good. When you evaluate that system, you can say the system is not good because it is entirely dependent on the accuracy or the correctness of user's input, right? And system is purely controlled by that. So it is not good to have a system which is entirely controlled by the user's knowledge or user's accuracy. So that's why it is coming under this head like limitations. Now, second is possibly you can say it is no support to the ranking process or ranking strategy. It is not providing you any ranked list of retrieved documents. So it is again a limitation. Third could be this phenomena called dictionary mismatch. So dictionary mismatch says sometimes user supply a keyword to the system, and it is possible that that keyword is having multiple interpretations, right? So you can have two interpretations, or that particular keyword is having two meanings of that, and system is not able to identify whether you're looking for one type of objects or looking for the second type of objects related to that in single query term. So in the case of Boolean, it is not having any ability or any semantic relations with the other results. It is simply performing AND base match. So it will not take care. It will not take care, or it will not have this capability to take care about this dictionary mismatch problem, which is one of the phenomenal issue in the retrieval or information search process. So you can have other limitations also. You can list down. If you have this idea, you can let me know. So what could be the possible other limitations we can have in the retrieval Boolean retrieval models? You can add these limitations based on your understanding. So probably you will have certainly a limitation with you. Now, based on these limitations, or you can say based on these observations, you can look for the next retrieval or next approach for retrieval. So primarily, they have worked upon these limitations and come up with a lot of solutions. So between these Boolean retrieval model and vector space, there are various models have been proposed. So that's what we have discussed in the previous class. The very first category, which we are saying is a classical retrieval model, we have 3-4 different types of retrieval model, like Boolean, then extended Boolean, then fuzzy set, right? So you can have, so there are various models proposed, before the evolution of vector space. So these 3 or 4 are considered as the classical retrieval models. After that, they have realized, or they have new representation. So all these first 4 retrieval model will have same representation for query and data. They will have more or less similar matching process. maybe they are having different, definitions for the operator, Boolean operator, or maybe the operators which are dealing with the scenario where we have more than one query terms in the query. But once we have different data, different scope of different representation, then you can have a new retrieval model. And that's why this vector space has been this presence in the retrieval model. So vector space representation, vector representation of data, vector representation of query is basically new evolution kind of scenario. So when we have observed that, okay, now most of the person are trying to represent their text data or their document data into the form of vectors, we can have new retrieval model now, right? So then we have realized that, okay, now we will be having new types of retrieval models where we will have this vector phenomena, vector concept for representation of query and data. So after transforming the user query into the vector representation, after performing the vector representation on the documents, we can have some approach to map them or to match them, right? We will have some strategy to identify the similarity between these query vectors and document vectors, right? So primarily it is proposed naturally to overcome the limitation of Boolean retrieval model. That's what the basic philosophy is, basic need is actually. But it is coming with three most important features of the modern retrieval systems. The first strategy is that it will provide a ranking, or it will provide the ranked list of retrieved documents. That's one of the important factor. Then it will provide some kind of weighting scheme, right? And this weighting scheme will have potential advantage for any retrieval process, for any retrieval model. And after that, it will accept, or it will have some strategy to incorporate the relevance feedback, right? So these three are, the benchmark, properties or features which are still available in the modern or maybe latest retrieval models. So VectorSpace model is the first model which incorporates these three features, and these three features are pivotal for any kind of retrieval model, right? So if you go for the basically degree of matching, it will have, again, degree of matching is having only two levels, matching and non-matching. But if you see among or within the matching degree, we have two possible levels. Now that's what we have indicated also. So VectorSpace model is the first model which incorporates the second level of matching or relevance. So relevant means exactly matching, and there are some documents which are partially matching. And VectorSpace model is something which incorporates this layer of relevance. It is considering, or it is having an approach to consider the documents which are partially matched, right? So whenever we will have set of documents as a result of VectorSpace retrieval, we will have some as a exactly matching or relevant. We will have some documents which are partially matching also. They might be appearing in the lower order of the ranking, but there will be some sort of documents, right? Now, when it comes to the representation model for query and data collection, so you can see we have talked about the vector space, right? So we will adapt some vector representation, and in case of this retrieval process, this retrieval model, we will have t-dimensional. So it will, because it is a vector representation, so you need to concern about the dimensions. So what is the dimension of vectors which we are talking about for query and data representation? So it will be t-dimensional. So t is naturally the number of index terms which we are considering. In the case of vector space, there is a concept called index database, which is widely used, which is a very important role having the success of effectiveness of a vector space. So we will be having vectors of t dimensions length. So t means t is basically index, number of index terms which we could have, right? Similarly, so this t dimension vector space is adapted for both query and data. And each document will be represented as a vector of, basically represented as a vector of index terms, right? So like if you take any document, di, it will be represented as di1, di2, some dit, as dij, which is a document, represents the weight of the jth term. So we are maintaining now, along with the query term within document, we are maintaining the weight or number of presence or number of frequency of each index term within a document, right? So typically, if you take these 4 documents, I hope you can see. Now we have shown these 4 documents, D1, D2, D3, and if you read D1, we have some set of terms. Similarly, D2, D3, D4, and if you maintain, vectors representation for the documents for these terms, so you can see this first term called aquarium is having presence into the document D1 with single frequency. D2 is having 1 frequency within it. For D3, it is having 1. For D4 document is having single presence. But if you see the last keyword or last term, it is topical. It is having his presence once in the D1, D2, D3 document, but in the case of D4 document, it is appearing twice. So we are maintaining, in case of vector space model, we are maintaining this term frequency, term weight within along with the vectors. So in the vector representation, we are maintaining the term and its weight, right, within each document. And this weight will help you to identify to place a particular document in the arranged list or in the ranked list after the retrieval, right? So similarly, for a user query also, you can have the similar representation for these query terms. So let's take one particular user query. So based on this representation which we have derived for the 4 documents and given text within each document, you can have this representation for D1 to D4 4 documents. And suppose there is a query called Q1 which has term tropical fish. It is having 2 terms. So if you map into the representation which we have wrapped it, which is vector representation, it could be like this. So it is having the presence of tropical and fish. So it will be like 3 zeros, 1s, and then 0s and 1s. So it is having the presence of these 2 terms. So now we have successfully mapped the user query into the vector representation and documents and their inputs in the form of vectors. Now, because we have achieved to a particular representation, now next task is to have a mechanism which identifies or which matches or which derives some similarity between this query vector representation with each document vector representation. So you need to have some strategy to define a similarity between document vector and query vector. So for that, you can always adapt some sort of approaches. Some are saying, okay, similarity approach is good. Some says distance measure approach is good. So you can always have your own way of doing it, right? So it is not very specific or limited to any particular measure or any particular approach to derive the define the similarity or closeness between the query vector and document vector, right? So in the next lecture, we will be discussing about the these similarity measures, because similarity measure is something which is considered as the suitable for vector space-based retrieval model. So whenever for your search system you're trying to have this vector representation for user and document query, you can have any similarity measure, right? Yes, we have this distance measure based approaches also, but similarity based measures are widely accepted. We have some sort of idea about these similarity measures in the previous class. We have taken out the names also, like cosine similarity, Jaccard similarity. So there are 6-7 different ways of doing it. Some people have started exploring the non-similarity or dissimilarity measures also to identify the closeness between the user query vector and document query vector. So in the next lecture, we will discuss about these measures and how you can observe some limitation onto the vector space retrieval model also, right? So that is it for the today's lecture. So now if you have anything to share, you